Okay, so let's go ahead and start from scratch again. I'm going to go to File, New, and this says this project was modified. Just say discard, and we go back to PBR Metallic Rough HQ High Quality. The mesh we're going to select is going to be our garbage low res. We can go ahead and delete this if we wish. It's kind of just been used for the fun of it. And I'm going to go ahead and do the garbage low res. DirectX, we'll leave the document resolution at 2048. Depending on your computer speed or the power of your computer, you could do 2048 or 4096. I'm going to go ahead and switch this to 4096 now because my computer can handle it. But if you have a kind of a crummy laptop, I'd probably be working at 2048. You can, at any one time, especially when you're ready to bake your texture maps, go over to 4096. The beauty of Substance Painter, like I discussed earlier, is it's a series of movie projections. As you go to a movie, you see the projector behind you projecting onto the actual screen. Every single paint stroke you make, every single thing you do is recorded in history in Substance Painter as a projection-based reality or some procedural operation. And hence, you can at any one time, and not worrying about, bottlenecking your resolution, go up and down these resolutions based on the speed of your computer, how much details you have, and eventually, when you're ready, render it out at 4096 if you wish. So it also depends on the resolution of the images you bring in, which is important, but I like to work at high resolution as possible, so I'm going to keep this at 4096. And I'm going to go ahead and hit OK. And now you can see, once again, we only have one piece of geometry in this scene. You can turn it on and off, and this is a texture set or a piece of geometry. So I'm going to go ahead and call this my garbage bin, keep things nice and tidy, as you can see. Now you probably wonder, how can I isolate the idea of texturing different pieces? Well, that's where our actual map came in as far as the baking of the map. So we'll get into that a little bit later. The texture set settings. Okay, so this is the big place we want to start with. You can see we currently have base color, height, roughness, metallic, and normal that we can paint. You can even see that here under our properties bin. So again, you have your 3D view, you have your 2D texture view, you have your shelf, you have your layers, you have your texture set settings, your texture set, display setting, viewer settings, and you have your paint properties right here, as you can see. We're going to get into all this madness a little bit later, but I want to start with the texture set settings and how we're going to be dealing with that. Again, currently, I talked about this before, Substance Painter is basically a very smart masking program for texturing your object and allows you to paint with multiple paint strokes at one time. In other words, as I'm painting a color stroke, I'm also painting a height stroke, I'm also painting a roughness stroke, I'm also painting a metallic stroke, and I'm also painting a normal stroke. It is really amazing because that's the way we want to work, because we're not just painting a texture, we're painting a material. A material has many attributes, the specularity of it, the metallicness of it, and we want to paint those all together as we kind of go through this. Okay, so let's come down to the bottom here, and you can see we have the option here for Bake Textures. Okay, so we're going to go ahead and click on Bake Textures, and these are what I call helper maps. These will be used to establish the masks that will be used through your intelligent masking systems throughout Substance Painter, and we need them to exist. So I'm going to go ahead and hit Bake Textures, and here's where the magic happens. I don't want to not congratulate the folks at Algorithmic for the amazing program they created. They created an amazing program. But at the heart of Substance Painter is a very simplistic reality, and that is masking. Black and white based masks, height-based masks. Masking is what gives you the ability to create grunge around the corners of an object based on the concave and convex reality of geometry. And that's all figured out based on the normals, and the normals are the starting point. So making sure we have a good normal map is so imperative. You can see we're getting little exclamation points in these right here. So I'll go ahead and turn off these maps here. We're not going to create ID or ambient occlusion or position or thickness yet, or even world space. We're going to stick with the normal map, because believe it or not, the world map actually creates, the normal map creates all these other maps. So it's so important that we have a very clean and precise normal map, which will help create a very clean and precise ambient occlusion map, which will be used to build these other maps. So keep that in mind. So the output size of the actual map we're going to be creating is going to be 4096, because that's where the highest resolution we want. We don't want a blurred base mask. The dilation width, we're going to leave at 1. That has to do with like the kind of extra sort of expansion of the actual map that gets printed. So I'm not going to deal with that. Now you can see here it says use low poly mesh as high poly mesh, high definition meshes. Now you can turn this on if you don't intend to bring in a high poly mesh. Say you have a high poly mesh already and you're texturing it and you don't have a higher poly mesh to bake a normal based on. You would just click on this. But because we are not just using this signal geometry, we're actually going to be using the high-res geometry to kind of soften up those edges. And again, I'm going to go ahead and hit cancel here for a minute just so I can show you. If you want to move around here, it's Alt left mouse button and drag, just like in Maya. So again, Alt right mouse button, left and right is a zoom in. Alt middle mouse button is basically to kind of move up and down, and Alt left mouse button is to scrub around. So there's a lot of, you can also hit F to frame in case you kind of fall off the map. You can hit F to frame the object. So I can come around here and you can see already in our situation that we have a kind of reality of sharp edges. If you want to move the light around, we have a current lighting setup right now. You can go ahead and hold down the Shift key and the right mouse button, and you'll start to see these little hotkeys start to pop up to give you information here. See this? Like Shift B will do this. So forth. So I'm going to hit Shift and right mouse button and hold and drag my mouse left and right to change the lighting in the scene. And this is just rotating an HDRI map. So we'll get into that a little bit later. But you see that harsh, sharp edge there? This is the product of a low-res mesh. Nothing in the real world is that sharp, and that's going to make your audience all kind of question the quality of your work. Even like right here, you can see this here. Now, normal maps I talked about before give themselves away in the silhouette. So we're never going to be able to get rid of this sort of edge here unless we actually add more geometry. But if we were to look at the geometry here, right, without seeing the edge of the scene, this will actually transition very nicely when we actually bake out our actual normal map. So again, a normal map is a trick. It's a trick of the eye, and it's used in games to convince you that an area that actually has low res, like here would be one edge, is actually more edges and smoother. And it just keeps the poly count down and just does a really nice job. You can see right here we have this really nasty sharp edge here, right? All right, so let's go ahead and do the magic of the normal map. And we might get artifacts in this process, and that's how we're going to have to start diagnosing our issues based on the length of the distance when I talk about here in a minute. So I'm going to go ahead and jump over here to the Bake Texture Maps again. Again, turn off all these. They want you to bake all the maps at once, which is understandable. The normal map option here, again, you see this little problem here with the, it's giving sort of an exclamation point. It says it needs a high definition mesh. So anytime you see this, it means, hey, I need a high definition mesh. Now you can kind of figure that, you can kind of cancel that problem out by turning this on if you're just going to use this as the mesh. But that's what it is. So I'm going to go ahead and it says bring in your high definition mesh. I'm going to make sure this is unclicked, and I'm going to go ahead and click here, and we're going to bring in our garbage HR or high res mesh. Now you can see there's no error message anymore on any of these maps because it actually has a high-res mesh. Now here's where the fun comes. The max frontal distance, the cage file has to do with sort of a change and alteration of distances. The max frontal distance and max rear distance is something I want to get into a little bit here. There is also relative to bounding box, average normals, ignore backface. I don't want to get into all these super high-level details, but one of the big ones I want to get into is this high poly mesh and low poly mesh name. Each one of these pieces of geometry, if you remember, was separate. So let's go ahead and jump back into Maya and just take a look at them really quick. So I'm going to jump back into Maya. And these meshes have the name low res, right? Let's go ahead and take a look at the names of these things. So underscore low underscore res, right? And then the high poly faces had high res. So it's R-E-Z, right? So low and high with an underscore. Very important we remember that underscore. So I'm going to go back into Substance Painter really quick here. And I'm going to go ahead and say, well, the high res is high res. This is how it's going to identify the individual pieces of geometry and avoid artifacts during the bake around the edges of the scene if we do, depending on what we do. So I'm going to do high res and low res. Now, case sensitive is important too. So if you recall, if I go back into Maya here, I put capital letters here, high res. So it's going to look for that string of information and basically parent together the only pieces of geometry that should be based on each other to bake against each other versus low res versus high res. I know it seems a little bit complicated. Don't freak out. So again, we have that. Anti-aliasing, we definitely want to put this to 4x4, otherwise we're going to have kind of a stair-step effect on some of the artifacts. And we could do, let's see, all these are fine. Yeah, everything's fine here. Ignore backface matching. You can do by mesh name. Now, it is already using by mesh name, but when it comes to backface match, you might get a shadow under here or not. Again, look for artifacts. We're going to be kind of looking for artifacts and kind of redoing these bakes over and over again until we get a good result. So the max frontal and the max rear distance, let me kind of discuss that inside of Maya really quick. So I'm going to go quickly into Maya really briefly. And as you recall, I have my low-res scene set up here. I'm going to go take my high-res group really quick, and I'm going to put this to 0. And let's go ahead and just do an X-ray of this. And I want you to see the difference in the geometry here, especially around this edge here. This is a perfect example here. You can see right here that this is our low res and this is our high res, right? Well, the distance is based on relative units with inside of, if you have the default setting, it's based on the percentage difference, which is kind of hard to measure in regards to searching out and searching in. So in this case, what's going to happen is it's going to take the low res, and then from the normals direction, which is why normals were so important, it's going to search out a certain amount of units and look for geometry. It's going to search in and look for a certain amount of geometry. And in that process, it's going to kind of scan this here and bake a normal map on that. That's going to basically be a fake map that kind of makes it look like the high res, right? The silhouette will always give itself away, like right here, but it's going to pretend that there's a smoothness that came here. Now, the issue that occurs is if your distance isn't long enough, as far as like in this case, going backwards, it may not reach to this point and realize there's a point here, but it will, if the distance is, good enough here, it'll kind of think, oh, well, there's really just one division across like this. So it'll give you a smooth effect, but not two-division smooth effect. So it's important that your frontal and back is giving enough reach to gather information, because sometimes this will actually bow out a little bit in high res, and to get all that information that's behind or below and scan that. Now, the problem occurs in when you have thick versus thin areas in a universal setting for distance matching, because you can get an inverse where this can actually go searching below and actually go through a piece of geometry accidentally, and it'll give you some weird artifacts. So it's kind of confusing at first, and there's a lot of workarounds. Some people use Marmoset Toolbag, which is a program to bake the normal maps and build their own cages for the distances, because the distance of what I would search here, okay, searching enough to see it, not going too far to penetrate some other geometry that's down here. Okay, but at the same time, if we use that same universal baking resolution for, say, this piece right here, let's go ahead and just grab it. Right, look at this. All right, I'll go ahead and grab this teeny tiny piece and hit F. Let's say I did some work on here. It's going to scan out like this, and it's going to freak out because it's going to go so far, it's going to go all the way out here and get the back end of this piece of geometry. So that's how you can get artifacts when you put like a universal based numeric value for this. So let's go ahead and jump into Substance Painter and kind of just do some bakes and see what happens, So I have it all by default. I'm going to use again the frontal distance and the max distance, and you can see it says relative to bounding box. So this is a percentage distance from the bounding box. If I wanted to use real world units in centimeters, I can turn this off and plug in a centimeter distance inside. How can I measure a centimeter distance? Well, you can go into Maya, for instance, and I'll just do an example here. This is a lot of technical guru crap, and you're probably going, oh, I don't want to hear this. But just listen to it, okay? So I'm going to go to Create Measuring Tool, Distance Tool, and I'm going to use my Snap to Point tool here. I'll turn on Wireframe on Shaded, and I'm going to click here and here. So just to give you an idea, in regards to the distances here. And let's make sure I get out of this. There we go. You know, you could look at this and go, okay, so the distance in centimeters is like 0.1 because Maya has default centimeters for its measuring tool, so 0.18. Okay, so for instance, if I wanted this piece of geometry, I'll go ahead and snap this right here and take this right here. And if it was going to kind of look, you know, in an opposite distance here, make sure I have one of these guys selected. There we go. And I'd want to search it out. Go ahead and just zoom in here so you can see. You know, I would say I need to be at least 0.101, right? But I don't want to go any further because if I go all the way down, I might, you know, scan the bottom of this piece of geometry or something, right? Obviously. So you're putting a universal value in here that works really well with this, right? But that same distance in real skinny pieces right here will create artifacts because it's going through the other side of the geometry. So there is ways of kind of dealing with that on a per mesh basis, and that's why we labeled these high-res, low-res meshes, so that we can do that. So let's see the difference between the two and see how they work. Again, blah, 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 but I need you to kind of just hang with me here. So I'm going to turn this back to relative to Bounding Box. I'm going to leave the default settings and just see what we get. So again, I have my high-res in. I'm going to bake on my map, and I'm going to say bake garbage bin textures, which is obviously the mesh itself. Okay. If you had multiple pieces of geometry, you can do it for all of them, actually, which is nice. So again, just bake the normal map, turn all these off, have this as your settings. Again, my output size, I want to make sure it's set to 4096 by 4096. And I'm going to go ahead and bake. Now, you might want to go get a cup of coffee with high-resolution bakes. If you're doing 2048 by 2048, it won't be an issue. So I'm going to go ahead and hit pause, and we'll come back. Okay, we're back. That actually didn't happen too far off. And because we're in Substance Painter, and Substance Painter currently is rendering in DirectX, we can see the fruits of our labor in the form of the normal map. So again, I can come in here and you turn my light around right here. And you can see there might be a little bit of artifacting here along the edge. See that? And what I can do probably is just come in here and change up a couple settings to make this look nicer. So you have your display settings and you have your viewer settings. So under my viewer setting, display settings, I can do things such as turn on active post process, and I can turn on anti-aliasing. And that should kind of get rid of the aliasing edge here. But you can see in general, it's giving me a nice result. You might see something that might be tricky to deter. Like you can see, it looks like there's a line there. See that? Looks like there's a kind of a shape of a line. But in general, it looks pretty good. Let's take a look at the other pieces of geometry here. Okay, so we're getting something weird going on right here. See that? And you're probably wondering, like, what happened there? What was going on there? Well, the normals of this actual wall reached out and touched this piece of geometry and sampled back. And that's why we're getting what looks like almost like a shadowing effect. And the same thing happened with this piece of geometry. It actually grabbed part of this wall and pulled it in based on a distance. Now here's the really cool part. Take a look around our actual hole here where you put the garbage in. We're getting a nice smooth transition. You see that? Yeah, these edges are sharp here, but in general, this is nice and smooth. This right here looks really nice and smooth. And the tops of this everything looks really beautiful. Let's take a look at our rack. And our rack is going to be tricky because, as you can see, if I kind of move in here, the rack on this side, the silhouette of the normal map kind of gives away the trick of the normal map, which you can see right here. We still see the divisions that we had, but look at when we're looking directly face on or facing towards, you will see that it looks like it has a nice smooth transition. See that? Now if I come around the other side, you can see this looks really nice, right? It looks like it was smooth, but it doesn't look like it's smooth when I give it around the silhouette. And this is how game engines, if you guys ever played a video game, you'll notice the edge of the characters might have this rickety edge of low poly count, but yet when you look at them straight on, they have like a nice smooth surface. And that's the trick and the beauty of a normal map. Let's go ahead and come down here and see what we got. And again, we're looking for artifacts. Like you could say this is an artifact right here. You can see it. Some of this might have to do with where the actual UVs are laid out. You can see this guy right here. See this line? So if we go ahead and kind of take a look and kind of do some investigation here on our normal map, and you can see here that this is basically, when you're looking through these, you're looking through these with a material on it. So there's a certain level of reflectivity and so forth. If you want to look at the individual maps, you can go ahead and type the whatchamacallit, let's see here, the letter C. So if I hit the letter C, you can see all the different maps that we've created. In this case, it's hard to see what they're. Let me go move out a little bit here. This is the base color, which there is no color. That's why it's checkerboard. The height map, there's nothing there yet. Roughness map, nothing there yet. Metallic, nothing there yet. Normal map, that's us actual texturing normals. There's a difference between your normal map that's been baked and then your normal map that you've painted yet. And then you get normal plus height plus base normal. So what we basically baked was called a base normal. Okay, which is also going to be used as a helper map, but it is a base normal. So here you have the base normal plus the height and normal information, which we haven't painted yet. So if we create more bumpiness later on, it'll add these together. And these basically comprise what will be your eventual output of your normal or bump map. So we can see artifacts if we come around here, right? And we can switch back with the letter M, as in Mary. And you can see that interesting reality there. Now, is that an artifact or not? Or is that something with the hardware texturing issues? It's hard to tell. Honestly, let's come down here and take a look. And again, you can see here on our regular map, if we come down here, you can see this is the normal map itself, which looks like it's holding up pretty good. It's giving that harsh edge, but it's transitioning it. And again, I'll go back to M to see the final product, as you can see here. Now let's play a little bit. We can always re-project or recreate our actual normal map. So all you gotta do is go back to Bake Textures, and now we have, you know, the actual max frontal distance and rear distance. Well, all the settings are the same, so let's go ahead and do this again. And I'm gonna go ahead and choose max frontal distance to something even crazier. Let's bring this all the way up to like 0.5. Let's see if that makes a difference. Now we're going to watch live as we do this. I'm going to do 0.55. Make sure you make these numbers exactly the same if you need to. You don't always have to go, you know, sometimes you got information that's more pushing out than pushing in, then you can kind of go inverse. Like for instance, if I take the max frontal distance, right, if we recall from Maya, let's go back into Maya real quick. And you can see in Maya, you know, if this is our starting point, we only have to go in the negative or the below instead of going out, right? So let's play with that. Again, we're having a little fun here. We're just having a little bit of fun. So the max rear distance, or going backwards, we'll leave that, and then the max frontal distance, we'll leave it 0, right? Now let's go ahead and hit a bake and see what happens. Keep an eye on this edge here, because we're about to see it update. Watch the magic. And again, just playing around, which should be good practice on your end. Part of Substance Painter is getting the normal map right. If you get the normal map wrong, you are so in trouble when it comes to the eventual maps that are built off your normal map, such as your occlusion map and your other maps, and your curvature map. And those maps will actually make artifacts in areas where you want to add dirt and dust. Okay, so there we go. And you can see we got basically the same result. Sometimes it looks good, sometimes it doesn't. Okay, let's go ahead and bake again. Go Bake Textures, and I'm going to go ahead and put this again just to put 0.5 and 0.5. Let's try those together, and again I'll do Bake Garbage Bin again. I'm just going to keep playing until I see something. Just see what happens. See the way the light interacts. Just because it kind of may display weird here in Substance Painter doesn't mean it's wrong. Okay. But it does give you a clue, hey, something might be wrong with the way that you bake this. And there we go. And again, you can just move the light around. You can see that this, I think, has probably made it worse. And you see why it's making it worse? The reason why it's making it worse is because it's reaching further out. So our distance is even more, and it's reaching out to more geometry. You're probably going to see more of an artifact over here. Now you can see it like it reached out more. We could see a shadowing. See that? This piece of geometry actually reached out so far as here and grabbed it and pulled it back and painted that normal map information in, which is not what we want. So it looks like we need a very small distance, and here's a perfect example right here. You can see that we're baking, this reached out so far, and look at how far it reached out, percentage-wise, right? It reached so far out that it went that far. So we need to decrease our value. This is telling me I need to decrease my value, okay, of what's going on. And this is great for you to watch. You have to learn from your mistakes with this, or you really will never really understand or master Substance Painter in the baking process. So I'm going to do one last thing here, additional maps. And this time I'm going to bake this to, let's go all the way down to, let's choose a value of like 0.001. 0.001. What I like to do is I'll start low, like 0.01 and 0.01. Oops, I'll go and do it again here, 0.01. It's going to be a very small distance. Again, this is based relative to Bounty Box, not centimeters. If I want to use actual centimeters, I can. I can just turn this off and plug in the values, which is something we might do. We'll see. So I'm going to go ahead and do Bake Garbage Bin Textures. And there you can see it's looking good, but let's see how well it does around these corners. We're still getting this strange artifact right here. Let's take a look. Yeah, still got that weird line. Again, that could be an issue. It could be a lot of issues. We'll see. And let's see the other areas. This is looking really nice. Let's take a look at our issue here. We're still getting this. See that? And this is because it's reading the geometries. It's baking the normal maps based on one thing and one thing alone, and that is the reality of their real positions and distances. Now, we can come in here and do a bake based on the individual geometries separate, as if they don't see each other. But that can create artifacts when we get to the process of building out the actual occlusion path. So we're going to see, I'm going to show you that in a minute. So let's go ahead and do another bake, and I'll leave these for defaults, right? Except this time, instead of the match, we're going to go ahead and use by mesh name only. So in other words, and what this means is this garbage, this little rotary here, will not read the information coming in from this here. Okay, when it bakes, it's going to just use the low res of the rotary and the high res of the rotary, and compare the two, and it'll be as if these pieces don't exist. And again, this all depends on you making sure that this is correctly named high res and low res based on your meshes. So I'm going to go ahead and do it right now. Let's see what we get. Okay, so let's see what happened. Take a look. We are not getting that artifact anymore around the edge here, which is beautiful, right? We are getting that nice, as you can see here, as I hold down left and right mouse button, we're getting a nice transition. We are not getting that artifact because, again, as I mentioned before, it took this individual piece of geometry, the mesh, based on that extension we created in Maya, and compared the high res to the low res, back and forth, but it didn't sample these areas out here and didn't give us that artifact. Let's see how everything else looks. We're still getting this here, but this might just be an artifact. I don't know, I'm not totally convinced. I'm not sure why that's still acting up. We might do one more bake. This is looking really nice. This might be, I think this might be a hardware issue. I don't think this might be an issue. You can see that line right there. It might be just a hardware issue inside of Substance Painter or my actual video card. I don't know. We'll see. But you can see how nice and nicely transitioned these areas are. Look very, very nice. And again, we'll go back over here. If we look from a distance, this looks good. Now, one way to render this, or to know whether or not this is an artifact or not, is to actually render this inside of what's called iRay. So iRay is actually as if you render this using, say, Arnold and Maya or something, which is really cool. And then you'll know if this is an artifact or not. So I'm going to go over here and render this out. So if you go to mode, you can go to rendering iRay. Now there's also a little camera here we can click on that, and we're going to jump into this awesome iRay program. And voila, you can see, and again, you can move around just like in Maya. It gives you a very fast feedback. This gives you an idea what you're going to get rendered out of Maya. So you can see this is just normal. This is the fact that we never did smooth this geometry here, but we are getting a nice look photorealistically as far as a bevel around these edges, around this edge. Let's go ahead and take a look over here. This is looking good. You want to run around this thing and look for any weird artifacts. And from what I can tell, the ground here looks pretty good. And again, you can also hold down Shift and right mouse button and move the lighting around, which is kind of cool. Your lighting situation here is based on an HDRI. So you can see there's an HDRI in your scene. You can change that out. I believe you can just change it out right here. So under Viewer Settings and Environment Map, we can choose all types of different maps in here. So I can use a soft 2-ring. You can see the shapes. These are studio lights way at the bottom. You want to use these because they're not like an environment. And let's use a soft 1 front light, which is just a light, which puts this big blob in your scene. And now you can start to see a harsh shadow setup. And now I can go ahead and spin the light around. And it's looking pretty solid. I'm not seeing any artifact. Again, a lot of it could be hardware based, but we're getting a nice result here. A very, very nice result. So let's go on to our next lesson, and we're going to learn about how to start to bake out from our normal map now that it's created, and creating our different maps such as our curvature map as well as our occlusion map, which are all based on our normal map.